To solve this equation, we're going to use a zero factor property that says if two numbers, say a times b, equals 0, then at least one of them has to be 0. Then a equals 0 or b equals 0, or maybe both. So what we have is that I've got this might be the a, this might be the b. So I've got one number times another number equaling 0. So at least one of them has to be 0. So I could write this, that 11r plus 6 has to be equal to 0, or that 5r minus 15 has to be 0. Now let's solve each one separately. So I'll solve this one first. So I'm going to subtract 6, divide by 11. So I'll get 11r equals negative 6, divide by 11, I'll get r is equal to negative 6 over 11. Or, now let's solve this one. So I'm going to add 15, then divide by 5. So I'll get 5r equals, add 15, I'll get 15, divide by 5, we'll get r is equal to 15 divided by 5 is 3. So I'm going to claim that the solutions, there's two of them here, negative 6 over 11 and 3. Now, when you have something like this, you can either write all the steps, or if you're just doing it for yourself, if it's not an exam and you have to show your work, you can just write the solutions. Look what happens here. See, in this one, I've got something times something. Look what happens. I get negative 6 over 11. Negative 6 over 11 down here. So what happens? Just change the sign of the constant, divide by the coefficient. Negative 6 divided by 11. And then over here, change the sign of the constant. Negative 15 becomes positive 15 over 5. 15 over 5 is 3. So just change the sign of the constant, divide by the coefficient. Now we've got a quadratic equation. What I would like to do is try to get it into this form back over here where I have it factored. Then I can use a zero factor property. So let's factor. So I'm going to write two sets of parentheses anticipating that I can do this. Don't forget to equal 0. So we're going to get t and t. Now, the factors of 27 that give us 6. Well, if you're not sure, here's 27. You can write it as 27 times 1. Now, I can't divide it by 2, but I can divide it by 3. So divide it by 3. I'll divide by 3 and triple. So I'll get 9 and triple 1, I get 3. Now 9 and 3, I can get a 6 out of that, right, if I subtract them. So I'm going to use a 9 and a 3. Now, this sign is negative. So I'm going to put that middle sign, that negative 6, that negative, with the bigger of these two products. So look at these products. I get 3t and 9t. This one's bigger. So I'm going to put that negative sign right there with the bigger product. So I'll get negative 9 plus 3. So just run a quick check. T squared, 3t minus 9t is minus 6t, and then minus 27. Now I can just read off the solution. From this one, I get t equals 9. From this one, I get t equals negative 3. Now if you don't see it, you have the zero factor property where this is one number times another number, so one of them has to be 0. So t minus 9 could be 0, or t plus 3 could be 0. Solve this one, solve the one on the left, we'll just add 9. We'll get t equals 9. Solve the one on the right, we'll subtract 3. T is negative 3. But if you can see it up here, this is real good. All right, so let's just write the solutions as t equals 9 and negative 3. Two solutions to that quadratic. This quadratic equation has no linear term. Notice there's a squared term and a constant. The way I'm going to deal with this is just separate the two. So I'm going to add 10. I'll get 5x squared equals 10. Let's divide by 5. So we'll get x squared equals 2. And now I'm going to take the square root of both sides. So I'll get the square root of x squared equals square root of 2. Now, be careful here. The square root of x squared is the absolute value of x. And that's going to be, can't do anything about square root of 2. That's simplified. And the absolute value of x, well, this could be plus or minus square root of 2. Number 4, I think this is going to work pretty much the same way as numbers 3. They're already separated. terms are already separated. Let's divide by 3. We'll get x squared equals 7. I'll take the square root of each side. That gives me absolute value. Square root of x squared is the absolute value of x. Square root of 7 I can't simplify. But now when I remove the absolute values, x could be square root of 7 or negative square root of 7. In number 5, let's divide by 3. It's almost the same as number 4. Let's divide by 3. I'll get x squared equals 5. Take square root of each side. Absolute square root of x squared is the absolute value of x. Square root of 5 we can't simplify. But now, what numbers could you put in for x to get square root of 5? So x could be square root of 5 or negative square root of 5. All right, again, we've got a squared term and a constant. Let's separate them. So I'll get x squared equals negative 1. Now take square roots. Square root of x squared equals square root of negative 1. Square root of x squared is the absolute value of x. Square root of negative 1 is I. So remove the absolute values. Now we get the plus or minus. Now we've got all three terms, and it looks like it's a cubic. So here's what I'm going to do. I notice there's nothing common between the 7 and the 62 and the 9, but there is a y in each term, right? I've got 3 y's here, 2 y's here, and a y here. So let's start by factoring out a y. We'll get y equals 7y squared minus 62y minus 9 equals 0. Now, let's see if we can factor this trinomial here. We'll get y. I'm going to write the 2 sets of parentheses, anticipating I can do this. Now, the first term, 7y squared. Only one way to get to 7 because it's prime, so I'll get 7y and y. Now, what about this 9? Well, there's 2 ways to get the 9, right? We could use a 9 and a 1, or a 3 and a 3. Now, I want to pick the pair, if either one of these pairs works, that is going to give me a 62. I need a number here and a number here that when I take the outer product, add it to the inner product, I get 62. Now, the 3 and the 3, I don't think this is going to work, right? If I put a 3 here and a 3 here, I'll just get 3 times 7 is 21, and a 3, I can't get a 62 out of that. But the 9 and the 1, I think that'll work. If I put the 9 here, I'll get 9 times 7 is 63, and the 1 here, I can get back to a 62. So a 9 and the 1, I think, is our choice. I'm going to put a 9 here and a 1 here. Now, what sign do we use? I notice that up here that 9 is negative. So these two numbers, the 1 and the 9, have opposite signs. I will put that negative sign with the bigger of the two products. So what do we have? The outer product is 63y. That is way bigger than 1y. So I'm going to put that minus sign right there with the bigger product. So I'm going to put the negative here, the positive here. Now just check it. Negative 63 plus 1 is negative 62. We have it. Now I can read off the solution. Here's what I'll have. I've got 3 terms here, right? Now this is a cubic. Look back at the beginning. It's a cubic, so I'm going to have 3 solutions. I'm going to get one from here. I'll get one from here, and I'll get one from here. So let's just read them off now. So we'll get y is equal to 0. That's from here. From this one, we'll get, remember what to do? Change the sign of the constant. Change the sign of the constant, divide by the coefficient. So we'll get negative 1 over 7. And from this last one here, we'll get a 9. There are our 3 solutions. Problem 8, it says to use the graph to find the intercepts, the x-intercepts, and the zeros of the function. All right, so let's look at this graph here. It starts here, here's 0. This is negative 10, so where are we? The intercepts, okay, the x-intercepts. So I got one right here, and I've got one right here, little red dots. So where are they? Let's count them out here. To the left, here's 0. 1, 2, 3, 4, 5. So it looks like I'm at negative 5, and to the right, 1, 2, 3, 4. We count that. 1, 2, 3, 4, 5, 6 to the right. All right, so let me write those down while I'm remembering it. X equals 6. And let me just count it to the left again to be sure. 1, 2, 3, 4, 5. Right, so I'm thinking negative 5. So actually what I have, this is part B. These are the zeros of the function, and the x-intercepts are at 6 and 0 and negative 5 and 0. The intercepts, remember, are actually points, and the zeros are the numbers that produce y equals 0 in the function. Let's solve this equation here by completing the square. Now, it's already in the proper form. The proper form being, I have the variables on one side and the constant on the other. So here's how we do this. You just, as long as this coefficient here is 1, which it is, just take half of this middle coefficient, take half of the linear coefficient, square it, add it to both sides. All right, so I'm going to take half of this, which is 4, and I'm going to square it, add it to both sides. And the way I'm going to do that is this. I'm going to take x squared plus 8x. Now take half of that 8, which is 4, square it. You know what I'll do? I'll do 4 squared so you can see what I'm doing. Add it to both sides. 9 plus 4 squared. All right, so this is the process. The process says to, as long as you have a 1 out here, take half of that middle coefficient, 4, square it. I did that. Add it to both sides. All right, now that's going to give us this. This side over here, the whole reason we do that is you get x plus, now half of that coefficient, 4 squared. You get that quantity squared is equal to 9 plus 16. I'll do it over here. So we get x plus 4 squared equals 25. Right, now are you okay back here? The reason we added that, you take half of this number, square it, add it to both sides. It makes this trinomial a perfect square, and it will factor as x and then plus, or just half of that. Plus 4, half of plus 8 is plus 4. Now, I've got something squared equaling a number, right? I got something squared equaling a number. So take the square root of both sides. I'll get the square root of x plus 4 squared equals square root of 25. Now, square root of the square is the absolute value of x plus 4. That's equal to square root of 25 is 5. Now when you take the absolute values off, you get plus or minus. I'll do it up here at the top right. So now I'll get x plus 4 equals plus or minus 5. I'll subtract the 4, so I'll get x is equal to negative 4 plus 5, plus or minus 5. Now there's two numbers here. X is equal to negative 4 plus 5 and negative 4 minus 5. So we'll get x equals, now negative 4 plus 5 is a 1. Negative 4 minus 5 is negative 9. So now let's look back over here and see what we're supposed to do. It says choose the appropriate process. Okay, well, x squared plus 8x equals 9. They're dividing by 8. That's ridiculous. So that one's out. What about this one? Plus 8 plus, okay. This looks like it could work here. This one is not going to work. I'm adding something to the left side, but not the right side. That one is out. This one, again, I'm dividing by that 8. That's not going to work. I think what we're at here is this one here. I'm going to take half of this number, square it, add it to both sides. Now we're going to solve this equation by completing the square to obtain exact solutions. So it's not quite in the right form. I want all the x's on one side. So I'm going to write it as x squared minus 4x equals negative 2. Now I know what to do here. I'm going to take half of this. I'm going to take half of this negative 4. All right, and if I take half of negative 4, I'll get negative 2, square it, add it to both sides. So I'm going to get x, whoops. So I'm going to get x squared minus 4x, and then I'm going to get I'm going to take this. I'm going to add negative 2 squared to both sides. Now, negative 2 squared is just 4, so I'm just going to do that here. All right, now here's what we end up on this side here. This is going to be x, because I have a 1 out here, I can just write it like this. X, and then half of this. Half of negative 4 is negative 2 squared, and that's equal to negative 2 plus 4 is 2. Now I've got a number squared equaling a number. Take square roots, both sides. Square root of the quantity x minus 2 squared is equal to the square root of 2. Now, the square root of the square root of the square is the absolute value, x minus 2. That's equal to, can't simplify that, but now I can remove the absolute value, so now I get a plus or minus. So I get x minus 2 equals plus or minus square root of 2. One more step, let's just add 2, so we'll get x equals 2 plus or minus square root of 2. Now, which one of these up here are we going to select? Well, what are we doing? Well, they're going to take, the first one divides by 4. We're not going to do that. This one, that's what I think we want to do, right? We're going to subtract the 4x. So we got a chance here. And what are we going to do? This says just to add something to one side. We need to add something to both sides. So how about this? I'm going to have x squared minus 4x, and then I'm going to add half of this, half of that to, well, half of this one here, half that to each side. So I'll get negative 2. There we go. I think it's this one right here. This one only adds something to one side. So let's select C.